Our final look at unit testing is going to explore the world of test patterns. Test patterns enable us to take an overall perspective of testing at a higher level of abstraction and look at some commonalities across the different tests we've written to date, and also explore other test strategies and methods. So we'll start with unit patterns in general, and we'll then move on to talk about test doubles, a specific range of unit testing techniques. This is a quite influential text, xunit patterns, which is worth having a peek at. Most of it is online now as an online catalogue, and it documents a large range of approaches to unit test development, covering the basics, automation, fixtures, how we organize tests, how testing databases has evolved, and then a very important topic is design for testability. These patterns have been organized into separate graphical mind maps, really, which I'm showing a snapshot of on the right here. And as you go through the catalog, I think some of those patterns should jump out at you now at this stage with the testing we've done to date. We're going to look at just this xunit basics patterns for a second. And let's just look at the different components of this diagram here on the right. For writing unit tests, we're trying to execute them, and we generally have a unit test runner that's built into Eclipse. You've seen that. It shows up each of the tests we're running, and it gives us a green or a red based on whether we pass or fail. You've seen that also interacts with a test suite object, which we've been building, and also a test case object, which we've been building. So those kind of things have been in operation since we started using tests immediately. Note also that these test runners are built into Maven, because you've been able to type Maven test, and a test runner, a non-graphical one, has been running in the context of Maven, and it has been able to explore the suites and then enumerate the tests, run each test, and give us a test pass or fail. Now let's also turn our attention to test definition and how we go about writing it. And again, this is something you're becoming familiar with. You've been writing test methods, and these test methods have been allowing us to write our unit tests to stimulate and then verify behavior across a range of the features we've been implementing. One of these test definitions, though, I want to explore a little more detail, and that's called the 4-phase test. Let's have a look at that. 4-phase test, think of it as a pattern. That is a way of thinking about many of the tests we've already written. And let's look at the components of a 4-phase test and compare it with some of the tests you have devised in your assignment 1. We talk about an SUT in this catalog, SUT standing for System Under Test. So in our case, that's been the Pacemaker API and model classes. And we're trying to develop a series of tests that advance the SUT, advance the SUT, or stimulate it, or elaborate on its behavior. 4-phase test, these 4 phases: setup, exercise, verify, and tear down. You're probably familiar with this. We verify, we set up the fixture first. That is, we set up some test data, and we may interact with the SUT to put it into a desired state. Second phase, we continue interacting with the SUT and stimulate the feature we're interested in verifying. Third phase, we determine whether the outcome has been as we expected. And the fourth phase, we tear down. That is, we dispose of any of the test information we may have been accumulating to ensure that subsequent tests are not interfered with. Here's one of the tests we developed earlier for our XML serializer. A long time ago now, we introduced that almost on the very first class. This was an elaboration of it in the sample solution, creating a serializer, creating a pacemaker, populating the serializer, store our populated models in the pacemaker, and then we're trying to create another pacemaker object, load it, and see did it deserialize correctly. So we're serializing and deserializing to XML, and we're attempting to verify if this test actually stimulates the correct behavior. That's a classic 4-phase test. You can see the setup here: serializer, pacemaker, population. We're generally configuring our SUT, system under test, with a fairly sophisticated model. Phase 2 is the exercising the particular feature we're testing. We're storing it to XML. Phase 3, we're loading it up again into a different pacemaker object, and then we're doing a comparison to see is the loaded model equivalent to the model we stored in the setup. And in the teardown, we're getting rid of our data store file just in case another test might be inadvertently loading it. Another example from the same project. Here we're testing adding activities with a single location. So we're creating a pacemaker object, creating some users. For a specific user, we're creating activity. We're adding an activity with a location. Then we're reading back that activity and verifying that we got the route we were expecting along with the activity itself. Also a 4-phase test. The setup is spread over the setup method and the body of the test itself. So the setup is articulated here. You can see phase 2 is the exercise, and phase 3 is the verification. Phase 4 teardown is taking place in the teardown method, which we've annotated with after. Again, classic 4-phase test in operation here. Now, why do we give it that name, and what does it mean? Well, the key point about the 4-phase test is that it's very common, and it can be clearly identified by the reader of the test. The reader of the test can see the intention fairly quickly, can see each of the 4 phases, and can understand and grasp the key feature that is being tested. Key point about this is that we're trying to avoid obscure tests. If the test is obfuscated in any way, or it's challenging to understand what's happening, then the test has a limited value. And it's important that the test is fairly obvious, fairly easy to read. Probably that it doesn't contain any logic, because any logic, any if statements or branches of any kind would suggest a complex test which is going to be difficult to understand and also maintain longer term. 4-phase test, if we're familiar with the pattern, as we now are, means we can recognize that very clearly in many of the tests we write. So this test, it's one of many patterns in this particular catalog, and I think you've been using it very much in the assignments and labs we've been doing to date. Some other patterns: result verification patterns. How do we verify that after we stimulated the SUT, the system under test, that the result is as we would have expected? Well, there are a number of ways of doing this. We've been largely focused on state verification. That is, we have had a look into the state after the system has been exercised, and we're comparing that state usually with a known good state. There are other ways and other types of verification that would be appropriate in different contexts. Behavior verification might involve trying to look at the system under test and look at a variety of interactions it should have had, perhaps with external systems. So we'd be verifying its behavior by checking those external systems to see have they been interacted with in the appropriate manner. This would be a type of behavior verification, and we'll be looking at that again in the next presentation. Other aspects here you've seen a little bit of: custom assertion. Well, we've hardly seen much of that, but you might have seen we talked a little bit about it when we introduced the concept of a bearing when we were exploring unit tests originally, and a specific unit test around bearings. Delta assertions, well, we've just seen delta assertions in action. This is where we're trying to make sure that the result is within a given range. You must use delta assertions when you're comparing floats, for instance, otherwise you get round off errors. Test organization patterns. We've largely been keeping our tests fairly simple, really. So we have implemented test class per class. So we've been adopting this pattern here. So we've had, say, activities tests, or we've had users tests. But there are other ways of organizing tests, as you can see. We could have a test class per feature, whereby we would perhaps have, imagine a locations test, for instance, whereby we had grouped the 2 or 3 tests we had on locations into its own class, and then that test class was stimulating the features only. A useful way of thinking about the tests. Fixtures. How could we organize those? Well, there's a whole range of choices here and a range of options. We've been keeping a fairly simple-minded fixture in that we've developed a single fixture class, if you might recall. And this has been a pre-built fixture which has been shared across all the tests we've been assembling. So we've been looking at something like this, and we've also been sharing our fixture across multiple tests. Teardown patterns. Well, there's implicit teardown and explicit teardown. Implicit teardown we've probably also seen in action, in that we've been using the annotation methods before and after, which is implicit. That could be more explicit. We've done explicit occasionally, and there are other options there that are toured in this pattern. Database patterns. Well, that's a whole world in its own, really, and quite a specialized area. We haven't really touched on this at all, really. Trying to simulate a database or establish a fake database, as you can see here, are common approaches to the challenges associated with databases. And there is even a suite of tools, DB-unit tools you may have come across, which portray or fulfill a role somewhat similar to xunit, but specifically customized to have test runners and simulations associated with databases and specific types of databases. The last one is test doubles. We're going to look at this in a little bit more detail in the next talk, but this is an important area that you should be familiar with. This text xunit test patterns is definitely worth checking out. Particularly this review here is worth checking. It's a short read, and then if you follow the links from there, you will see a catalogue of the patterns that I've been discussing in this talk.